Hello all, welcome to this video on System Software Lab. Today I'll be talking about pass 1 and 2 of a 2-pass assembler. In the previous video I had talked about 2-pass assemblers and some of its features. Now in this video we'll be looking into how each of these pass works. Now in case of a simple SIC assembler, the translation of source code to object code needs the mnemonic codes to be converted to equivalent machine codes, the symbolic labels to be converted to equivalent machine address, building machine instructions in proper format, converting of data constants into internal machine representation, and writing the object program and assembly listing. Now we'll look into the different data structures used here. The first one is optab or operation code table. It is used to look up mnemonic operation codes and translate them into their machine language equivalent. More complex assemblers contain information about instruction format and length. They look up and validate operation codes in source program in pass 1. It also increases the location counter by length. They translate opcode to machine code including the format in pass 2. It is organized as a hash table, which will give it a faster retrieval with minimum searching, using mnemonic operation code as key. In most cases, it is a static table where the information is predefined when the assembler itself is written. Next is a symtab or symbol table. It is used to store name and value or addresses for each label in source program with flags to indicate error conditions. For example, a symbol defined in 2 different places. In pass 1, the labels are entered along with their addresses from the location counter. In pass 2, the labels are looked up to get addresses to insert in assembled instructions. It is also organized as a hash table where the entries are rarely deleted. This table is heavily used throughout the assembly. Now we'll see what a location counter is. It helps in the assignment of address. It is initialized as the address in start. After each source statement is processed, the length of the assembled instruction or data area to be generated is added to the location counter. When encountering a label, the current location counter gives the address of the label. Now we look into the different passes of a 2-pass assembler. During pass 1, the input is the program for pass 1 and optab. The output is the intermediate file, symtab, and the length of the program. Pass 1 assign addresses to all the statements in the source code. It also save values, that is the addresses from the location counter, assigned to labels into the symtab for use in pass 2. It also processes some directives. This includes processing that affects the address assignment, such as determining the length of data areas defined by byte, reserve word, etc. Now we look into what is the connection between pass 1 and pass 2. It is possible for both passes of the assembler to read the original source program as input. However, there is certain information such as the location counter values and error flags for statements that should be communicated between the 2 passes. Pass 1 writes an intermediate file that contains each source statement together with its assigned address, error indicators, etc. This field is used as input to pass 2. This working copy of the source program can also be used to retain results of certain operations that may be performed during pass 1, such as the scanning operand field for symbols and addressing flags. So these need not be performed again during pass 2. Similarly, pointers to optab and symtab may be retained for each operation code and symbol used. This avoids the need to repeat many of the table searching operations. Now let us look into pass 2. Pass 2 assemble the instructions, that is, operands are looked up in symtab to obtain addresses to insert in the assembled instructions. It also generates data values defined by byte and word. It processes the instructions, that is the directives, which was not done in pass 1. Finally, it writes the object code and assembly listing. Now, assembly listing contains both the statements in the source file and the binary code, if any, generated for each statement. The listing show the name and values of all labels, variables, and symbols in the file. Now we look into pass 1. Now, as I have already said, two inputs are the input file, which will contain the code, optab, which is given to the program of pass 1, and it generates the output, symtab, the intermediate file, which I have given the name output.txt, and the length file, where the length of the program will be written. Now we look into the algorithm for pass 1. As written here, the first input line is read, and first it checks whether the first opcode entered is start or not. So if it is start, it means it will be followed by some starting address, if any. So it will save the operand, whatever is given after start, as the starting address. So since it is the starting address, the location counter will also be given the same value. And the first line, which is the starting line, will be written to the intermediate file. And the next line is read. Now, if there is no address present after the start, it means the location counter value will be set to 0. Now, the statements following this will have to be repeated until the opcode found is not equal to end. So if there are any command lines, then they are skipped. So after ensuring if a particular statement is not a comment, it will check if there is a symbol in the label field of the instruction. So for example, this is how the values from the table are read. That is the label followed by the opcode and the operand. The start and end I had mentioned before are the opcodes that is checked. In this example, you can see start is followed by an address. So this will be value of the location counter and the starting address. Now, the lines following, it checks if the opcode is end or not. Whenever the end opcode is found, it means the program has reached the end. Until then, what it does is, as we saw before, it will check if there is any kind of symbol present in the label field. If so, what it does is, it will check in the symtab whether it has such a label or not. If the label is present in the symtab, it is actually marked with an error flag, because once a symbol is recorded in the symtab, the next time you try to record it again, there will be an error. That is, there is a chance of duplication. So if that label is not present in the symtab, what it does is it will insert the label and the location counter value in that particular statement to symtab, which will act as the address of the label. Now, after all those are completed, next it will search the optab for the particular opcode. Now, if a match is found, then it adds 3 to the location counter. Now 3 here stands for the instruction length. Now if by any chance the opcode is word, then also 3 is added to the location counter. If the opcode is a reserve word, then it will multiply 3 with the operand and add it to the location counter. Else, if the opcode is a reserved byte, it will simply add the operand to the location counter. Else, if the opcode is byte, it will take the length of the constant in bytes and that length is added to the location counter. Now, if any invalid opcode is found, it will be marked with an error flag. Now, all these data are parallelly written to the intermediate file. This is repeated until the opcode is not end. And the last line is written to the intermediate file. And finally, we'll calculate the length of the program by subtracting the starting address from the location counter. And that marks the end of pass 1. Now we'll look into how the program logic that I'll be showing here is going to work. Now I have declared 5 file pointers, one to the input file, optab file, symtab file. The output file here is the intermediate output and the length file. As seen before in the algorithm, we take in the first line, which is in the label opcode operand format. Actually, all the lines follow this format. So there might be differences based on whether all the fields are occupied or if some are left empty or not. Now this is taken from the input file and it is checked. If it's a start, then whatever operand follows it will be the starting address and location counter. And the same statement need not need any processing done. So that will be directly written to the intermediate file, which is the output.txt here. So if it's not a start, it will be marked to the location counter value, which is 0. So in both pass 1 and pass 2 that I'll be doing here, in the references that I have seen, they have explained it in terms of hexadecimal values. That is, the location counter, the address, the length of the program, etc. are given in hexadecimal. Since we can only print the values in hexadecimal in C and there is no other option to have any variable in hexadecimal data format, what I'll do is I'll have two types of output here. So whatever output I'll write in the file will be in decimal format. All the numbers, the location counter updation will be in the decimal format, and whatever I'll print on the terminal will be in hex format. The number updation, that is the location counter updation, will be done in hex format. So in order to take into according both of the files, that is, I'll be setting two location counters. So the location counter LOCCTR will be managing the decimal conversion and location disp will be managing the hex output, which will be seen in the terminal. So here the starting address is 2000. What I did is I have set location disp to 8192, which is the decimal value of 2000, so that when I print it as hex in the terminal, it will display it as 2000. Next, these are the steps to be repeated until the opcode is not end. The location counter value is recorded when each statement is read out. And we check here if there is any label or not. So since there is no label there, it's marked with an asterisk, 2 asterisk. So we check if the label is not an asterisk, we'll enter the label and the location counter value to the symtab. Then what we do is we'll take the mnemonic and the opcode from optab, which looks like this. Now this is the content from a symtab where we have the label and the location counter. Then what I do is the following steps will be repeated until the mnemonic value is not end. So if it will check if the opcode and the mnemonic matches. Accordingly, location counter is updated with 3. Next mnemonic is read. If it's a word, it adds 3. If it's a reserved by word, then it takes 3 and multiplies it with the operand. So here the operand is 2. So 3 into 2 will be 6. Here it is simply adding 3 even though we have a 5 here because the size of a word is 3 bytes. Then if the opcode is a byte, we'll simply add the operand to the location counter. Here operand is 1, so 1 is added to the location counter. Then if the opcode is a byte, it will take the length of the constant following byte. Here the length is 1, so 1 is added to the location counter. Finally, the label, opcode and operand are written to the intermediate file or output text here. Then the length is calculated. Now the length will be written into the file. Now all these calculations are happening in the decimal format. Finally, all the file pointers are closed. Now this is what the input looks like. This is the label field, opcode field and the operand field. This is the optab. This is the program whose logic I explained just now. Then this is the output from the file. You can see that here all these updations are done in decimal format. Now this is the output, that is the length of the file. And this is the output I was talking about, which is the terminal output, which is in hexadecimal format. Also note that whenever I updated location counter, I also updated the LOCCTR, which is the location counter in hexadecimal format also. You can see the difference here. This is in hex and this is in decimal. And also the starting address and the program length here is 17. Actually, 17 is the hex value of 23. This is one of the outputs, which is a symtab. You can see the label followed by the location counter value. Next, we look into pass 2 as explained before. Symtab, optab, length and output, which is the intermediate file, will go as input to the program for pass 2. And finally, the object code is generated. This is the algorithm. As in the previous case, each input line will be taken and it checks whether the opcode is a start. Then if it's a start, no assembling is needed, so the line will be directly written to the listing file and next input line will be read in. After the first line is completed, it will start writing the header record to the object program. Then it will write the text record following the header record. Again, it checks that the opcode is never reaching an end. If it reaches an end, it means the program ends. So until the opcode is end, it will skip all the command lines and search for opcode inside the optab. If that particular opcode matches, then it will check if there is a symbol in the operand field. For example, now this is an example of the header record and the text record we were specifying before. And after it finds a match for that operand in symtab, it will store that symbol value as the operand address. And if it is not found, it will store it as 0 because it couldn't find that symbol in the symbol table. Means it's an invalid symbol. So it's marked with a 0. And if the case here is that if the opcode is not found, then its operand address will be stored as 0 and the object code instruction will be assembled accordingly. Then it checks if the opcode is a byte or a word. If it is so, then it is converting its constant to the corresponding object code. And if the object code will not fit into the current text record, then you will start writing the next text record. In the previous video, I had discussed that the length of each text record can have only 30 bytes, that is 2 columns per byte. So maximum there is 60 columns. So if anything exceeds that, it will be written in as a new text record. Now inside the text record, the object code is written and the corresponding listing line follows it. And after all these steps are completed, the last text record will be written and finally the end record to mark the end of the program, followed by the last listing line, and that's how pass 2 ends. Now we'll see the program logic for pass 2. Here again I have some file pointers for a file called sample. Now we have already seen the format of object code in the previous video. So it has 3 sections: header, text and end record. So inside the text record, after mentioning the starting address of each text record, it is expected to have the length of each text record. But since I can get the length only after processing the object code, what I do is, all the object codes generated, I'll take it and store it in a file called sample. So when I print the final output, I'll print the length first, then I'll read the content I stored in the sample file and print it after that. That is why this file is present here. Then we have the intermediate or output file, optab, symtab and length file. As in the previous case, the first statement will contain the starting address, so that is read in, and the same line is written as such into the final output file. That is the operand address, the starting address is taken and written into the file. Then we'll check if it is start, then we'll set start to this operand address and we'll read the length from the length file. Then the header record is written where the H is followed by the label here, that is the name of the control section, which is copy, following the starting address and the length of the program. Then we start writing the text record, which begins with the starting address. You can see that each of the entry that is converted into the object code, whether it being the length or the address, it will contain 6 digits. So this already has 4, so I am adding 2 zeros before it. So there will be a total of 6 digits. So whenever I update the record length for each text record, I'll take into consideration 6 for each of the object code. That is why I'm adding 6 to the variable called record length. Then I'll read the location counter, label, opcode, operand, that is the output of pass 1. Then I'll repeat the following steps until the opcode is end. I'll read the mnemonic and opcode, and if there is a match between the opcode and the mnemonic, then I'll read the symbol from the symbol table. And if the operand and the symbol name are the same, then I'll print it out. That is, if for example the opcode is LDA followed by a label, what I'll do is, this code will stand for the hex equivalent of this mnemonic, and this sim location is the location counter value of that particular label following it. So there also I'll have 6 digits, that is why I'm adding 6 to the record length. Then I'll check if it's a word. Same way, word in this example I'm giving only 1 digit operands here, so I'll add 5 zeros. the record length will be updated by a 6. If it is byte, then same way I am using it as a single digit entry here, so I'll add 5 zeros before it, and that is also recorded into the record length. Then I'll reset the files each time the iteration repeats. Then I'll close the sample file because I am done writing the object code into it. Then I'll open it in read mode. Now, as I said before, there is a maximum of 60 columns, but the size is only 30, that is 60 divided by 2. So the record length will be divided by 2, and that will be taken in hexadecimal value. That will be the length of each text record. Then after the length is printed for each text record, it will be followed by the contents in the sample.txt following the end record. So end record will contain the address of the first executable instruction in object program, which will be replaced in the start field given here. And finally, all the file pointers will be closed. This is a sample of how the output here looks like. So this is the header record. This is copy, which you can call as the program name or the name of the control section we use here. Then we have the starting address of the object program, that is in hexadecimal. Then we have the length of the object program, which is a byte value given again in hexadecimal, followed by the text record. So this is the starting address of the text record. 15 is the text record length. Since this program has only a few lines of code, we have only a single text record. So 15 is the hex value of the length. And this is the object code for the opcode. LDA, it is 00, and the location counter value for the label 5 is 2018. Similarly, we see STA is 0C, alpha will have location counter value 2012, LDCH as the opcode as 50 for example, and the char result label has the location counter as 2021. Then we have STCH with opcode 54 and the C1 having location counter value 2022, and it follows on. Finally, we have the end record where we have the address of the first executable instruction in the object program. Now this is the length file, one of the inputs to pass2. This is the program for pass2, and this is how the output looks like. As I have said before, pass2 will have only a single output. All of it is in hexadecimal. As you can see, the name of the control section, the address, the length, all of it are given in 6-digit values. Then the text record followed by the length and the object code for all the other lines of code, and finally the end record and the address of the first executable instruction. Now this is the entry that I had written to the sample file. So the portion from this 002018 to 00078 was written into the sample file, so that after calculating all these I could get the length. So what I did is I printed the length followed by reading the content of this file and printing it here. Now we look into a demo of how this program is run. So the inputs are pass1 file and optab. Then we will compile the program. Finally executing it. This is the location counter values in hex. All the values are in hex here. And if we go to the output, we have symtab, the intermediate file, and the length. That was the symtab. This is the intermediate file where all the values are in decimal, and this is the length, again 23, which is in decimal. Now going for pass 2, we have the code for pass 2, and we have other inputs too to pass 2, which are optab, symtab, the intermediate or output file, and the length. Then we are compiling the same, and on running it, we get the object file record as header record, text record, end record. This was the sample file I was talking about. That's all for now. Thank you for watching.